Hello there. This video is a team effort made to enlighten you about functions and the different ways of representing them. During your junior high school years, topics such as integers, polynomials, geometry, and trigonometry were discussed in detail by your teachers. And now that you have reached this far, it's time to introduce you to the world of functions. So what is a function? Functions are relations that have only one output per input. Functions show us that for every element in the domain, it corresponds to only one element in the range. They are denoted by a single letter, often as f or f of x. Think of functions as a machine. We take the input, the raw material, then perform the given operations, and then transform it into something else, which is the output or the product. Remember that the notion f of x can be read as the value of f at x, the function of x, or simply f of x, with f signifying the function and x being the placeholder of the domain. Other letters may be used to denote the function. So what types of relation can and cannot be classified as a function? Relations can be classified as functions only if a domain value equates to only one range value. That means functions can be one-to-one, many-to-one, but never a one-to-many relation.
One-to-one correspondence. Table of values for f of x is equal to 6x minus 35. F of x is equal to set element 1 and negative 29, 2 and negative 23, 3 and negative 17, 4 and negative 11, 5 and negative 5. Observe the table and check whether a domain is shared by two ranges. Since it is clear that none of the x values are repeated, this relation is one-to-one. One-to-one functions show that for one element in the domain, it corresponds to only one element in the range. Here's another example of a one-to-one function. Table of values for f of x is equal to 4x plus 16. F of x is equal to set element 1 and 20, 3 and 28, 5 and 36, 7 and 44, 9 and 52. Again, observe the table and check if any x values are shared by two y values. As you can tell, there are no domain elements shared or repeated throughout the table. We can conclude the expression y is equal to 4x plus 16 is indeed a one-to-one function.
Many-to-one correspondence. Mapping diagram of set 2 and 3, 5 and 3, 8 and 4, 9 and 4, 14 and 6. X, 2, 5, 8, 9, 14. Y, 3, 4, 6. Based on the diagram, this is many-to-one relation. Only the y values were shared by multiple x values. Many-to-one relations are also considered functions, since there are no domain elements that are shared or repeated. Mapping diagram for set 1 and 4, 7 and 4, 10 and 8. X, 1, 7, 10. Y, 4 and 8. As shown on the second diagram, inputs 1 and 7 both result in the output 4, with input 10 being paired with output 8. This relation is also considered many-to-one relation because there are two x values that correspond to the y value.
One-to-many correspondence. Mapping diagram for set quantity 1, 2, 1, 4, 3, 6, 5, 6, 5, 7. This time, the relation is one-to-many, input to one result. In outputs 2 and 4, input 3 result in output 6 and 7. and input 5 result in output 4 and 6, function cannot contain x values that equate to 2 or more y values because it creates confusion and breaks the convention of what a function should be. Mapping diagram for set quantity NM, NO, IO, IR, SR, SK. Let's use letter for this example. Input N results in outputs M and O. Input I result and outputs O and R, and output S result in outputs R and K. If you are uncertain or stupefied of the true output for the relation, then this is not a function because it has a one-to-many correspondence.
The vertical line test. The vertical line test is used in graphs to determine whether it is a function or not. If it intersects vertical line at one point, it is a function. If it intersects the vertical line at two or more points, it is not a function. The red line intersects the blue line at one point, thus this is a quadratic function. The circle intersects blue line at 2 points, so it is not a function.
How can we represent functions, you ask? Functions can be represented in various ways, such as by making a table of values, mapping out the correspondence, plotting the given coordinates to illustrate a graph, listing the variables down as a set, or verbally representing it.
Table of values give us a simple view of correlation between given element in the domain and arranged by using the given inputs in a function. We are able to find the desired output and list them into its respective group. This method is one of the common ways of represent function.
Mapping diagram. Set elements A and B and C and B. Set elements CR, C and Z, UR, and U and C. Mapping diagram illustrates the relationship between domain and range elements in a more detailed manner. We can actually see the correspondence thanks to the lines that serve as bridges or links. This is also a common method to present functions.
Graphing using given coordinates. Representing functions can also be done through plotting given coordinates to create a graph. Using our previous example, f of x is equals to 6x minus 35 and its x and y values. We created a linear graph illustrating the expression.
Listing the elements down as a set. Set elements negative 9 and 11, negative 5 and 7, negative 1 and 3, 2 and negative 4, 8 and negative 6, 12 and negative 10. Domains elements equal negative 9, negative 5, negative 1, 2, 8, and 12. Range elements equal negative 10, negative 6, negative 4, 3, 7, and 11. Function could also represented as a set is revertible. You enumerate them in ascending order to pinpoint the graph more correctly. Each of the negative x and y values can be enumerated separately for us to identify what inputs and outputs are in the function.
Verbally representing the function. Functions can be represented verbally through text or speech. For example, a frozen pie was baked and taken out of the oven once it was done. What the problem requires us to do is to verbally describe what happened to the temperature of the pie when it was being baked and then left to cool, with a visual aid such as a graph. Here's a little reminder. There are certain functions that must be represented in a specific method to better understand what is needed to be solved. To summarize, functions are relations that have only one input and output. It can be one-to-one or many-to-one, but it cannot be a one-to-many relation. There are 5 ways to represent a function, such as by table of values, mapping diagram, graphing, grouping the elements into a set, or verbally representing it. Well, we've reached the end of the line. We hope you were able to learn a thing or two from this video. Thank you for watching.